let's have a look at maybe a helpful little way that we can remember how to navigate through these mass, mole, molecule, atom type conversions. This is called the mole valley. While I'd love to take credit for it, the credit actually belongs to a former student of mine. Let's say that we're going to imagine that we're actually walking from one unit to another. So I'm starting at grams and I'm looking to get to molecules or atoms. Molecules or atoms will depend on what the substance is. So I'm going to draw myself, or a random stick person here, starting at mass. And I'm going to actually draw what we're going to call a valley. So if I have my representative valley here, can I walk directly across the valley from mass to molecules? No, I can't. I have to go down through the valley. The bottom of the valley, the unit is moles. So in order to transition from a mass unit to, let's say, a unit of count like molecules or atoms, I must use the molar conversion. So descending the valley, going from mass to moles, what I'm essentially doing is I'm dividing by the molar mass. Remember, the molar mass is the mass that you would add up for any molecule using all the atoms using all of its atoms and their masses from the periodic table. Okay, if I'm going to look to convert from moles back to mass, I'm multiplying by the molar mass. Right. Now, while I would suggest you not memorize this multiply and divide, this can be helpful when we're learning it for the first time. If I'm looking to go from moles up to number of molecules, let's say, what I'm going to do is I'm actually going to multiply by Avogadro's number. So this is 6.02 times 10 to the power of 23. If I'm descending from molecules back down to moles, what I'm going to do is I'm going to divide by Avogadro's number. And this will give me number of moles from either number of molecules or atoms. Okay. So now, this business here between molecules and atoms, well, is your substance a molecule? If so, when you multiply, let's say, moles by Avogadro's number, you're going to get the number of molecules. Alright? If you need to find atoms, you're going to have to carry out an additional step. If you're dealing with a substance that, let's say, is something like copper, that's just an atom, when you multiply by Avogadro's number, you'll just get number of atoms. Alright? We're going to have a look at this additional step here. So, I'm going to give you an example. I'm going to keep the mole valley on the screen along with all the writing that I've done. Okay, how about we ask something somewhat straightforward, but that'll be multi-step. How many atoms are in 43.87 grams of ammonia? Right, so here's my question. This is my target. I need to start at mass. I cannot get directly to atoms. I'm going to have to do a few conversions here. I'm going to have to go from mass to moles. I'm going to have to go from moles to molecules. That gets me down the hill, back up the hill, and then I have to go between atoms because ammonia is a molecule that's made up of 4 atoms. So 43.87 grams of ammonia times 1 mole of ammonia divided by 17.04 grams of ammonia, that's the molar mass of ammonia. I'm going to multiply that by Avogadro's number to get back up the hill. Alright, you can see I'm putting all my units in so I can eliminate them algebraically. That's the end of that second step would give me a number of molecules. Now I'm going to say there's 4 atoms in a molecule of ammonia. If I work out my units, the only unit I'm going to be left with is atoms. So now I can just plug all of this in. 43.87 divided by 17.04 times Avogadro's number times 4. Okay, this is going to give me 6.199 times 10 to the power of 24. Atoms are in 43.87 grams of ammonia. We'll have a bunch of practice with this today, going from mass to moles, mass to molecules, number of atoms, all that sort of thing. Alright, I highly encourage you to write down your units as I've done and try actually eliminating the units before even going to solve the problems numerically.